Hello guys, welcome to homework number 16. I'll immediately share this right now for the solutions. So the first problem we have here says, domino toppling is an event in which a large number of dominoes are lined up close together and then allowed to topple one after the other. So the disturbance that propagates along the line of dominoes is, so along the lines of dominoes as they fall, you're going to have both transverse and partially or longitudinal. So it's partially transverse and partially longitudinal, or partly transverse, partly longitudinal. That's why the correct answer here is A. So because the dominoes themselves, they change position, unlike just the vibration, so, and they move parallel to each other. So it's a mixture of both the transverse wave property and longitudinal wave property. And then the next problem says a transverse wave on a string has an amplitude A. A tiny spot on the string is colored red. As one cycle of the wave passes by, what is the total distance traveled by the red spot? So you have the amplitude at the top of the cosine wave. So when it goes one amplitude down, another amplitude down for half the wave, another amplitude up, another amplitude up. So one amplitude up, one amplitude down is half a wavelength. Another amplitude up, another amplitude down. When you have a sine wave, that becomes 4 times the amplitude. That's why the correct answer is C for that. Okay. And then the next one says two strings have the same mass and the same length. The tension in the string 1 is 3 times the tension in string 2. So we know the speed is proportional to the square root of tension over mass per unit length. So if the tension of spring 1 is 3 times that of spring 2, the speed will be square root of 3 times the speed of the other one. So that's why the correct answer here is A. Okay. And then the next one says that as the amplitude of a sound wave in air decreases to 0, so what happens? So the condensations of the wave disappear, but nothing happens to the refractions. No, that's not correct. The condensations are just like the point of, when you have the tight point, and then refractions where you have the open point. So it's like for a transverse wave, the trough, the crest, and the troughs as a one-to-one correspondence per se. So the condensations and the refractions of the wave occupy more and more distance along the, no, that's not correct. So both the condensations and refractions of the wave disappear. Yes, that's what happens. So as it dies off, as the wave dies off, the amplitude dies off, the crest and the troughs at the same time, which is corresponding to the refractions and the condensations, they die off. So that's why the correct answer is E. Okay, then here, talking about tsunamis, chapter 16, problem 04. Tsunamis are fast-moving waves often generated by underwater earthquakes. In the deep ocean, the amplitude is barely noticeable. But here we are given one tsunami generated off the Aleutian Islands in Alaska, had the wavelength of that and traveled the distance of that in 5.6 hours. So what is the speed? So distance divided by time is speed. And from there, we can find the frequency and the period. So let's see how we do that. So the speed is distance divided by time. This is 398 kilometers to meters. You times to the 3 to get to meters in SI units divided by the time in hours. Then to convert these hours to seconds, you multiply by 1 hour divided by 3600 seconds. So your answer becomes meters per second. Then for the frequency, it's just the speed divided by the wavelength. So you are given the wavelength, 796 kilometers in the problem. So you're going to use that as multiplied times 10 to the 3 to convert to meters. So this speed divided by this wavelength will give you your frequency hertz. And period is just the inverse of frequency, 1 over the frequency you had above to get the answer for your period. And then next, chapter 16, problem 05 says, in the figure below, the hand moves the end of the slinky up and down through 2 complete cycles in 1 second. So 2 cycles per second, it's the number of cycles per second, that is the frequency. So 2 cycles per second is your frequency, which is 2 hertz you have here for frequency. And then you are given the speed to be 0.681 meters per second. So we can now get the distance between 2 adjacent crests is the same as the wavelength. So we are asked to find the wavelength, which is speed divided by the frequency, 2 complete cycles per second. And then you get that. And then the next problem is chapter 16, problem 12. It says that if the mass of a string is given to be this and it is stretched so that the tension is that, and the transverse wave on the string has a frequency of that and a wavelength of that, what is the length of the string? So the speed on a string is tension, which is F here, over mass per unit length, and is the same as frequency times lambda. So since you're not given the speed directly, we use frequency multiplied by lambda, equate that to the tension over mass per unit length. From there, we can get the length of the spring, L. So if we solve for L here, we're going to get L to be taking the square of both sides, F squared lambda squared times M over F. And we put the frequency squared that we are given, the lambda that we are given, the mass, and then the tension. Then we just get the length of the string right there. And then the last problem in this very short homework is chapter 16, problem 32, that says to navigate a porpoise emits a sound wave that has a wavelength of that. The speed travels, so we asked to find the period. So from the wavelength and the speed, we're going to convert this to SI units, 0.041 meters. We can get frequency to be speed over wavelength. So, but we don't know what is it called? The period that they're asking us to find is 1 over frequency. So that will be inverse of speed over wavelength. So that becomes wavelength over speed to get a period. Okay. So we just flip that upside down. Or you can just do the speed over wavelength first and then take the inverse of your answer. You're going to get the same thing for the period. So these are just really direct, simple problems. Yeah, I hope this is just a brief guide that helps you to know how to solve the problems. Thank you guys, and I'll see you guys next week.